lesson is looking at linear versus nonlinear functions. A linear function is a function that is in the form of a line. So one thing that can be said about a linear function is that it has a constant rate of change. Those are some key things there. So if we're looking at this one, it says what are the domain and the range. It is telling you specifically that it is a linear function, so that we know right away. The slope of this one has a slope of -3. Its a y-intercept is at 7. So we could start by plotting this at 0, 7, and then we would just follow our slope up 3/1 in the negative direction, and then we could follow it down 3/1 in the negative direction. The domain and the range of this one would be the set of all reals. The reason, if you're curious as to why it's the set of all reals, it would be because you can substitute in anything for x and you can substitute in anything for y. All right, using the average rate of change to identify a linear function. What we're doing here is anytime we have a constant rate of change. If you remember, constant rate of change would be our change in y over the change in x. So they're just doing that for you here in this example. And when you look at this average rate of change, or the change in y over the change in x, we consistently get -3, -3, -3, -3, -3. So this would be a linear function. Part of this then, because it has that constant rate of change, that would be considered our slope. Okay. These are two more word problems to kind of take a look at. Are these linear functions? I'll let you take a look at these and then flip over to the next page because it's going to show them in a table form. So we look at these in a table form. It's a little easier to see than that breakdown of that big old word problem. So we're going to use these tables then to compute the average rate of change. If we were going to do that ourselves, we would do the change in y over the change in x. So we would take these and subtract, and take these and subtract, and continue on in that fashion. However, luckily, this textbook has done it for us. These are the next two. One thing we can look at, I'm going to start here at this average rate of change. So if you look at this average rate of change, we have 0.03, 0.04, 0.06. That is not a constant rate of change. So therefore, this would be not linear or non-linear, either way you look at it. The other way that I can tell right away that this would be a non-linear function is because these dots do not go in a line. Our dots have to go in an absolute straight line in order to be linear. Looking at the next one, I can tell right away that my dots are in a line, and if I look at my average rate of change, it is linear, okay? I also can see that this is a linear function, but that it's decreasing. A couple reasons. One, they're all negative. My graph is going down. Next page wants us to determine if these functions are negative, positive, or constant. So the way we determine if a linear function is negative, positive, or constant is if our slope, or using our slope, if our slope is positive, it's increasing. If our slope is negative, it's decreasing. And if our slope is 0, it's constant. So let's take a look at A. Look at our slope. Our slope is always found right in front of our variable. So in front of this variable is 5. So A, it is increasing. B, I'm going to find my slope. My slope is found in front of my variable. My slope is a negative, so this is decreasing. C, take a look. My coefficient in front of my variable is a fraction. Granted, it's a fraction, but it is still a positive. It's a positive fraction, so it is increasing. And D, there is no variable, which means that we have a slope of 0, so this would be a constant. Strange with this video. I don't normally do this, but this really matches up very nicely. I'm going to pop over to the extra examples. I'm going to do a couple of those because the next 2 problems I'm going to do on the next video are going to be word problems. So extra example number 1 says determine the slope and y-intercept of the function. Use the slope to graph this, then determine the rate of change, and then determine if it is increasing, decreasing, or constant. So A, our slope is 2. Our y-intercept is 3. Use our slope and y-intercept to graph. So I'm going to go over to my graph, and I am going to start at my y-intercept, which is